Hello and welcome to this demo about the stream composition, data stream composition capabilities of Compose. So it corresponds to one of the deliverables of the project. The demo will be split into two different parts. In the first part, we will show how the data composition engine works. So we will provide an example of data composition and transformation and filtering. And in the second part, we will show a tool that we have developed basically to test the topology generation of the stream composition to create random topologies and test the performance of the platform. So let's start with the first part that is about stream composition. So basically the example that we will see is the following. We will have two emulated devices that are two web objects in the terminology of Compose. Each one of them is basically a smartphone, and we're supposing that each one of them is sending a stream of data, it's a continuous stream of data that is reporting the current location and the current temperature in Celsius degrees. So each one of them will have the corresponding counterpart in the platform, that is their service objects. So we will have two service objects, one for each one of the physical devices. And then we will have another service object that will be the one in charge of doing the composition, transformation, and filtering of data. So the second component that we will be showing is a sample user application that is an interactive map that will be querying data from the three of these service objects and will plot it in a map. So just a brief reminder of the architecture of what we are going to see. So we will have service objects, web objects outside of the platform. They will be sending data to the platform through the REST API that the Compose platform is providing. So after that, when a sensor update is received from each of them, this is going to be stored. And also, if there are any subscribers interested in that data, that basically is the service object that will be in charge of transforming and composing the data will be processed and forward to the service objects that are interested in that piece of data. So basically looking at the high-level picture of the architecture, so we have the API, we have the processing of service objects, we have external subscriptions, we have data storage, and we have data query capabilities. So basically, when the data from one of the service objects is forwarded to another one that is interested in composing or filtering or transforming the data, this piece of data goes through a service object pipeline. So basically, there are different stages through which the data will go, and in this demo we will focus on queries, that is basically defining what are the data sources for the composition. We have transformation, so basically we will transform Celsius degrees into Fahrenheit degrees. We will have filtering, that is, we will have another stream of data that will be filtering Fahrenheit temperatures that are only above 70 degrees. And then data is basically stored. So just as a reminder, the transformation stage, what it's actually doing is taking as an input a sensor update that is a JSON document describing different channels that are the multiple dimensions of one stream of data, and is going through a expression in JavaScript that is actually defining what is the transformation, filtering, etc. that this service object wants to perform, and the output that is produced after taking this piece of data through this process is another sensor update that can be stored, can be forwarded to anybody that is interested in real time, or can be further processed if needed. So this is the basic example demo that we will be showing. So we have the two devices that are sending location, that is coordinates and temperature. We have the service objects that are basically the endpoints inside the platform. The service objects receive the data about the temperature and the location and forward it to another service object that is interested in composing and transforming the data. And then there's another piece of a service object that is filtering the data. So this one transforms the Celsius degrees and aggregate the data that comes from these two devices into Fahrenheit degrees, and this one is filtering the data. So one important remark here is that this is not really two different service objects, but these are two streams from one service object, so from one service object. So we will show the definition of this compose structure. So the first service object that represents the first of the devices is shown here. So basically it has streams of data that is data. It has two channels, that is location, that is a geoposition, and temperature, that is basically a number in degrees. So this is the ID of the first service object. The second service object has a different ID, but has exactly the same structure. So this is a different device, but it's the same type of device. So it's providing the same location and temperature. So the service object that is aggregating data from both of them, what is actually expressing is that there's a group of service objects, that is the two IDs that we saw before, the data stream from both of them, that is actually the source of data for this service object. So this is not getting data directly from a web object outside the platform, but this is getting a source, the data that is absorbed, ingested by the other service objects. So it has the definition of two different streams. These are the output streams from this service object. So the first stream is the Fahrenheit. So this stream is actually taking the input from the other two service objects. So it's doing data composition, data aggregation, and it's doing a transformation. It's taking the temperature. So this is basically from members of group one, that is these two service objects. We take the channel's temperature current value property and we transform that into Fahrenheit. And we attach the same input location that the device was providing. And this is applied for any of the updates that these two devices are sending. So the output of this transformation is the Fahrenheit stream that this service object is emitting. So there's a second stream that is actually saying that it will take the outputs from Fahrenheit stream, so basically the one that we described just 1 minute ago, and it's filtering. So the filtering that it's doing is only values that are above 70 Fahrenheit degrees. So the flow again is two service objects produce data. This data is aggregated and transformed into Fahrenheit, and then this second stream is taking the output of this other and it's filtering outputs that are below 70 degrees. So only values above 70 will be emitted by this above 70 stream. So what will we see in the demo? So what we will see is in the display we will see 4 different maps, and each one of the maps will be showing a different set of data. So basically the map on the top left corner of the display will be showing data points from user 1. This other one will show data points from user 2. The window on the top right corner of the display will show the merging of data points from these two users, but the data will be already transformed in Fahrenheit degrees. And the the window on the bottom right corner of the display will show a subset of this information. That is only temperatures that are above 70 degrees. So this will be updated in real time. Every 5 seconds the display will refresh, and this is important to note that this is 4 windows that are actually doing queries, data queries to the platform. So they are every 5 seconds saying, give me all the points that are associated to this stream from this service object. And these are the 4 streams that we described before. So to start the demo, what we will see is in the database, we have different data buckets. So we have one that is for the service objects, that is the description of all of them. So this is the first one. I will make it larger for easier reading. So this is one of them. This is the first service object. This is basically the second one, and this is the one that is doing the actual composition that we were showing before. So what will happen next is that basically we have prepared here, so let's resize the windows. We have prepared here the 4 maps, and we will start pushing data into the platform, and we will see how information is populated here. So the other thing is that in these data buckets, this is the service object update. So this is the bucket in which we will see data. So this is currently empty. There are no items. So we cleared all the data in the platform before the demo. And now we will come here and we will start generating fake data. So this fake data will emit one sensor update for each one of the web objects every 4 seconds. So when we start producing data, we will see how data starts showing. So we see data points here, and you see this is the aggregation of both of them. And these are the points that are above 70 Fahrenheit degrees. So if we click here, we see that this is a temperature in this position. This is the location, and the temperature is 19 Celsius degrees. So when we click here, we can see that this position has 66 Fahrenheit degrees. So this is the transformation. And if we click here, we can see that, this point is not shown here. And this point that is here, that has temperature that is 76, that is above 70, is the one that we are seeing in the one that is doing the filtering. So as the information gets populated, we can see that there are several points like this one that are filtered out. So basically they are not reaching 70 degrees. And this is the aggregation of all of this information from the two originary service objects. So that's the composition, aggregation, and filtering that we were mentioning before. So we stop generating data. We come to the database. Maybe it's going to be a bit slow, because we did generate some data, and this is a local demo, so the machine is a bit overloaded. And we can see here how the different data points, so we will have a couple of pages of data points that have been generated, and we can come and see for each one of them what are the values, locations, etc. that we generated. So the other thing is that the Elasticsearch engine is basically getting updated with all the information, so we can check what are the sensor object updates. So this is what is being used also for reporting the information on the map and doing some fast queries on what are the points that are above 200 kilometers around the point in which we are clicking the map. So these are the search features that we can use afterwards on top of the data that has been generated. So the second part of the demo is the short demonstration about a topology generation tool. So when we create links between service objects, it can be seen how they are linked, and we can feed one service object with data that comes from another one. So to continue with the testing that we're doing about the platform, we have been developing a topology generation tool. So this is a tool that based on different configuration parameters that can be seen in this file. It is the configuration file. So we have different parameters that are the number of service objects, data streams that each one of them has, etc. Different group sizes. So these are static values now, but we are customizing the tool to be able to work with random variables of different types. So this tool is basically actually generating topologies of connections between service objects. It's generating the service objects, it's applying connections between them, connections between streams within service objects, across service objects. It's creating groups, and it's creating the topology. So based on that topology, it's able to make the connections, define the code for the transformation. So this is fake code that is randomly generated, but that is actually doing transformations on the data. And this is what we are using for testing the platform. So the next step is come and deploy the topology. So we deploy the topology. So this is going to generate a couple of service objects. So if we come to the database that we were seeing before, and we go to the service objects, so we will see that we have not only the three initial service objects, we have defined some of them that are random. So the topology has been deployed. We can come now and explore the topology. So this is going to open a window in which we will be able to see the topology that we have generated. So this is, oh, sorry. This was my fault. I think this is the window that has, no? So let's log in again. Let's make sure that we have X Windows support, because we need to create an external window. So now it's working. So we can see this is the topology that we have created. So this is basically a simple topology of 4 service objects that are connected across them. And this is the topology of the streams of the service objects and how they are connected. So based on this, we can go to the tool and check which is the entry point for this topology. What's the service object ID? That is the entry point. So the entry point is this code on here. This is the service object that is the entry point. So we can come here to the platform, and for this service object, we will generate a sensor update, and this sensor update will be generated here and will go through all the topology of the service objects that are connected. So we are ready here to look at the logs that we'll be generating. We prepare everything for looking at the logs. These are the logs from Storm that will be processing the information. So we come, send the sensor update. This has been accepted. So we see in Storm how different operations are taking place. And we see here how the tool is reporting what are the different steps that each sensor update went through. So we have IDs, timestamps, IDs of service objects, and conditions that make the flow continuous stop. And basically this is the logging that we will be performing to assess the performance of the application. So we have these topologies, we run them, we get the collection of performance metrics, and we will be exploring how the scalability of the system behaves under different sizes of topologies. So that's all for this demo. For more information, you can visit the Compose project webpage, and we also have this portal for the data plane that is servIoTicy.com, in which there are some useful information about the API for accessing the platform. So basically you have information to all the API for how to push data, retrieve data, etc. And you have also documentation about, for instance, how to create composite streams, all the step-by-step things that you have to do to do something similar to what we have been doing in this demo. And finally, you have a link also to a virtual appliance, so you can download this virtual appliance and run it locally, so you will have the entire platform locally available for testing and assessment. So thank you for listening, and that's everything for this demo.